we're going to go through a couple things in terms of EIGRP operations. Now, a lot of stuff, as far as, well, I suppose most of the things with EIGRP are really fairly straightforward and fairly simple to get through. Just like in RIP, there's two places for commands to exist. They can be under the routing process, in which case we can simply do a question mark, or they can be under an interface. Now, kind of like we talked about in the theory portion of the lectures here, the interface-based commands aren't quite as simple to get through as they are with RIP. So in RIP, it was IP RIP question mark. In EIGRP, well, it's IP something EIGRP, such as IP bandwidth EIGRP, or bandwidth percent, IP authentication EIGRP, IP summary address EIGRP. So it's a little bit more difficult to get through. Now, one of the things that we can do in terms of our command reference guide, I suppose we can back up here and click up on the EIGRP sections. Notice we have two separate EIGRP command reference guide tags or URLs that we can look at. There's still not a lot of commands in there. Now, I'd suggest going through them so we understand them all. Some things, such as the address family, we're not really needing to worry about. Same thing with exit address family, interface VMI. Some things are simply going to be service provider oriented. But as you go through and see the different commands on here, there's still going to be about, 15 or 20 commands that are worth getting to take a look at in there. Some of them being show commands, so it's always nice to be able to take a look at that information on there. But good part is that just by looking at this documentation here in these two particular pages, anything they ask you to do, we at least have a quick reference and can start to visually look at all of the options available to us. So when we get to the IP authentication, or the IP bandwidth percent, or the IP hello interval, or IP hold time, or whatever it is there, we don't have to worry about looking at the IP stuff and trying to figure out which things are for EIGRP and which things are for something entirely different. So take a look at the details in that. So back to our more exciting stuff here, though. So as we take a look at the different things in our topology, hasn't changed since the OSPF for the RIP, by the way. So our basics are still going to be the same here. And what I want to do is go ahead and enable EIGRP every place. So we can pretty much go to all routers, spell that correctly just for our own reference, and router, EIGRP, I don't know, whatever AS number we want to call it. Let's do 666 just for entertainment purposes. Network 0000, and you can put masks on here, but realistically, not going to do that, and kind of see where we end up getting and see how much information we end up seeing on here. Do probably, by the way, want to make no auto summary one of our base level commands to put in. So it keeps things a little bit simpler. So as we go through our different routers at this point, paste that in. Oh, you always love that. Sometimes a Windows copy does not keep the things you want to have copied. So, that was for clearing my lines on the terminal server before. Alright, good thing it wasn't my erasing the routers. That would have delayed things just a little bit. Okay, so we can start to see these things now in terms of where we're going to be heading or what information we're going to be getting to. It might also be worth our while. Let's go back to our diagram here. On router 1, router 9, and router 8 to go through and do some passive interfaces. I don't remember whether my backbone routers are running EIGRP, but it's probably a good bet to get in there and, at least tune that down so we don't get flooded with a bunch of routes. Because the stuff we're going to look at least initially, is not going to be as concerned with my backbone peering. And so let's go to R1, R8, and R9 and do that. So passive F01, and go over to router 8, say passive F00, and router 9, passive F00. Now, it didn't look like we had a neighbor adjacency there anyway, So we'll kind of take things one step at a time, though, and at least get through that portion. Now, since I'm on an edge router here anyway, let's take a look at what we do have. So my EIGRP route, so I get a decent number of stuff. It appears that I have at least all the rest of my loopback addresses in there, so this is certainly going to be a good thing. So 1, 2, 4, 5, 6, 7, and 8. Alright, so I get pingage from my loopbacks. This is a good thing. And, pretty much by that, if you feel like doing a tickle script to test things out, probably a good thing for testing, but from our standpoint, not really going to be a concern at this point. So looking back at our diagram, one of the big things that I want to address in here is load balancing, in terms of how we're going to do it and how that's going to manage itself. So when we see things such as our 5, 6, and 7, they're going to have multiple peers between them, basically for the same routes. So let's go over to R7 and take a look at some of the information on there. It looks like we got our peers up. Well, it looks like some of them went up before the no summary or no auto summary could be added. Wow, gotta love EIGRP. It is fast. Gotta give it some credit there. But let's see, do show IP route and see where we're at with things. All right. So what we're going to see on a number of different networks here. So in particular, we'll scroll down to the 200.0.0.1. So this particular path as it is, I have 4 options available to me. I can go via Fast Ethernet 0.1 or Fast Ethernet 0.0. The cost on all of these happens to be the same. So by default, what we have in EIGRP is equal cost load balancing. Take a look at our show IP protocols right there, and we'll have some information, well, pretty much available to us, in that we get maximum paths 4. So let's kind of look at a few different things going on. Now, I mean, I can certainly manipulate that. So I can say maximum paths, and nowadays we have between 1 and 16. It used to be between 1 and 6, but a few improvements, a few changes. So things being equal, that's the way that we're going to do basic load balancing. Now, when we do this, so let's see what a good way to kind of take a look at things is. Do trace 200.0.0.1 source loopback 0, and see where we get. Now notice that we get different outputs for each of the different hops that we have, simply based on how I'm sending it out and in the order that I happen to be sending it out on there. So those are going to be a little bit differences in terms of where we're going and how we're arranging it. So interestingly enough, it appears that our router 5 going to router 2 over there didn't really make it through for some reason. I'm sure there's some good value to that, because once you hit router 2, it's really not difficult to figure out how to get to router 1. But, whatever the reason for that is, at least we can see some differences in there. Looks like R1 must be thinking about something. So when we go through there, though, and see our options as far as load balancing goes, what do we got available to us? I mean, in this case, everything's going to be equal. Well, let's pop over to R5. So take a look at our diagram again real quick here, and notice that R5 has a serial link up to R2 as well as a frame relay link up to R2, but, over frame relay. So as we start looking at things in here, let's do show IP route, begin 200.0.0.1. Okay, now he's got 2 paths. One of them over the frame relay and one of them over the serial link. Again, costs being equal. Because, well, we haven't really done anything in order to manipulate that. We haven't done anything to change the bandwidth or manipulate our metrics, delay values, bandwidth values, or anything like that so far. Haven't cared. So how do we choose that number of paths or see what we're going to have in there? Well, from the topology table, the RIB. So looking at our topology table in here, we're going to see how many different successors we have for each of the different routes. So 200.0.0.1 has 2 successors, each of which happens to have the same value to them. So what if we change that? Can we go and change that? Let's see, what do we got? We've got do show interface. Just show interface. So serial 10, and we have 1.5 meg, and 20 also has 1.5 meg. Alright, so what if we change this now? So at this point in time, I'm still not going to see anything different. So why am I not going to see anything different? Alright, so I got 768K here versus 1.5 meg there. Alright, so at this point in time, I happen to see that my traffic share count is 1. Alright, so I'm going to see 1 bit of information on there. On here, I'm going to have 1 path. So why did we have 2 in the topology table? Believe it or not, I bet it's because of timing. Okay. So at this point in time, now we see I still have 2 pieces of information in here, but my values are going to be different. So that's why you only see 1 of them in there versus the other. So when we start looking at this now, so we decided that the bandwidth had to be updated. This, of course, drastically changes how many options I have available. Now, when I go back to R7, of course, is anything going to be changed? And really, the answer is no. Reason being, because every router makes its own individual decisions. Router 7 still has a total of 4 peering assignments there, so 2 peers over 2 interfaces each. And those allow me equal paths as we get to it. So that's the differences as far as where we're looking at for that version of load sharing. Now, back to R5. So when we start looking at this here, if I've gone through and my lab said, hey, change the bandwidth, so these are the results that I'm going to get, but then something later on says, oh, by the way, I want you to go ahead and change your load balancing on there. Question is, how are we going to do that? How are we actually going to make that happen in there? And, well, we've really got a variety of things that we can do. One of the simplest ones, of course, is the variance command. So variance is a multiplier for a metric. So what I'm going to do is I always pick based on the lowest metric that I have. So we'll see the do show IP route right here going up through 150, 125, 2. Scroll back down here, and that, of course, is my best metric. My variance command works on integers. So if I say variance of 2, that's going to be anything between 2.3 million and 2 times that, or 4.6 million. Now, this might be an issue if I had more than one thing or more than one additional path available to me. So say I had 3 or 4 different serial links that I was peering over and had some variety of metrics in there along that line. I might have to go through and do additional commands. So it may involve variance of 2, which as an example we'll just say that it allows 5 different paths to be chosen from a mathematical perspective. It'll choose the 5 best, by the way, but however many it's going to be. By default, my maximum pass is only 4. So the routing table is going to pick 4 of the RIB is going to pick 4 of the best of those in order to hand the routing table. So if I only wanted 2, then all I have to do is go and say maximum paths 2, and that's all that I would get on there, is whatever the 2 best ones happen to be. So taking a look at this now, so we saw the show IP route happens to be a bit different. So let's go back into my EIGRP, which is 666, I think. Probably a good thing to go ahead and check. Yeah, okay, that's cool. So if I say variance, yep, has to be a numerical or an integer value. But if I say variance of 2 now, so now I am back to having 2 paths. And notice in here that the metric really is different. But both paths are appearing as ready and available. So I can manipulate things or change things around in there based on how that happens to be balancing. So what happens when we do tracing information now? Okay, so we're going to see some balancing among this. Give us a little bit a viewpoint on here. Now, with that balancing in mind, there are a couple things that you might need to look at. All right. So when we're in our router configuration here, and I can do question mark on here, one of the things to look at is the traffic share command. So I've got balanced and I've got min. So what we have to do is take a look at, well, figuring out which choice that I'm going to get. So what is my default? Well, there's an easy way to show that actually. Try to type one in and figure out whether it shows up in show run or not. I don't know why they have you do a permanent command. There's only one option on there. So taking a look at this, if we do traffic share min, do show run, section EIGRP, and we see this actually show up. Now, let me go back and do that trace again. So if I do the trace after doing the traffic share min, what I'm going to see is my path only takes 150.125.2, which is my best metric path looking back at the topology table. So obviously traffic share min is not the default command. So traffic share balanced, on the other hand, is going to be my default command. Okay, notice nothing shows up there. Back to do my trace again, and I'll see balanced between those things, between all of the links. So I've used the variance command to allow them into the routing table, but if I did that traffic share min, well, basically I'd find that they wouldn't actually be used. Kind of defeats the purpose of putting them there, doesn't it? Well, fast convergence, I guess, would make some reason to have it there, but as far as our lab goes, really kind of defeats the purpose for it. So other things that you might get into when it comes to your traffic balancing. Once we have multiple paths available, the next step is how is that handled? And as far as iOS is concerned, traffic is routed or moved on a per flow basis. Now I don't see that with my traces here, because it's considered, well, stateless is kind of a fact, but really separate flows, separate conversations. Well, a flow is a unique source and destination as it appears in a timely fashion. So when we start going through with that, we might find really an unbalanced leverage of different links. So if I had an FTP session versus a telnet session as a point of interest there, obviously FTP takes a heck of a lot more bandwidth than telnet. No, I don't care how much you're typing for these labs, FTP still takes more bandwidth. But as you go through there, you might find that you want to have it more balanced over time. Well, there's actually interface commands that we can get into. So interface serial 10 or serial 20 for that matter. Say IP question mark. Yeah, we're going to see some of those EIGRP commands in here anyway. But one of the things that we're getting into is the style of load sharing. So we have per destination, which is the default, and we have per packet available to us. So that might be something else you actually get into in terms of how it's going to be load balanced. So if you want true, honest-to-God load balancing, you're going to not only need to do our traffic share balanced, but you're also going to have to change your IP load sharing to a per packet basis. Otherwise, there's really no way to determine that based on whatever applications that I truly get, 10 packets this way, 10 packets that way, 10 packets that way. So we gotta watch out for those details when we're talking about the load sharing information on here. But otherwise, that's the gist of all the things we get to be concerned about for our load sharing capabilities. So back to things showing up in my EIGRP table. So let's take a look. Let's see, what do we have on our diagram as far as other possibilities here? And it's really not much fun. There's not a whole heck of a lot we can do one way or the other. So let's say, well, we'll go ahead and still pick on R5. It's probably easier when we've got two links with separate bandwidths like that. Or we can just as easily do the same thing for R7, give ourselves two different links there. So let's cop down. Yeah, we'll do it on R7 just for fun. And take a look at our interfaces. So F00, 100 meg link, that's cool. F01, 100 meg link, that's cool. Okay, so our full duplex 100 meg is our speed at layer 1 that's been negotiated on there. The 100 megabit bandwidth is just an automatic calculation from that. So let's see, what can we do then to go into interface F01 and say bandwidth 10,000? So that basically means that we've got a 10 meg line here. Now if I go back and take a look at my interface, by the way, even though I will see this actually change, so 10,000 as opposed to 100,000, when it comes down to my actual operation, I'm still working at 100 meg. So the bandwidth command's not changing how anything is working. Now if I did speed 10, well, that would really affect both of them. But we're not. We're just changing the bandwidth on there. So let's go back then and take a look at our EIGRP table. So this is the rib for EIGRP. Now I'm still seeing all of my different neighbors here and all of the different options that I have available to me. And for right now, they're still seeing all of the same information there. So in the routing table, I still have 4 options in my calculations. So we might have to wait just a little while for the calculations to be completed. So let's take a pause and wait for some. So when we get down to looking at things finally, we'll find some differences in terms of our paths there. Notice that my fast Ethernet 00 paths have a different metric, a slightly better metric, than the fast Ethernet 01s do. When I look at my routing table now, what I should find is I don't have 4 paths in there. And that's right, I only have 2 of them over the fast Ethernet 00. So now, let's take a look at doing some load balancing where I might have a requirement, maybe something early in the lab changed my speeds or bandwidth or whatever. But now I have all of a sudden a requirement to do load balancing between these two, but do not use the variance command. Right? And other than the 2 that are obviously on the same interface there, R5 and R6, I want to do further where I get 4 paths available to me. So, taking a look at the options that you have, if we're not allowed to use the variance command, then somehow I've got to find a way to make that work. Now let's go up here. Okay, so here's the 4 paths I have from my different peers. Well, 2 of them got the same metric, and 2 other ones actually have the same metric also. Well, looking at my options, I'm going to pull up the calculator here for a minute just because I don't feel like doing addition in my head. We don't need the scientific calculator for this one, but if it makes you feel better, you can still use it. So 2200,576 minus 2177,536 equals 2,340. So, nope, 23,040. Always works to read it right. But this is why God invented copy and paste. So, as I start to look at this here, let's copy that information just to be sure. Go back and say, okay, how can I make this metric equal to that one. Well, we could go and change bandwidth and delay on an interface value. So that might be one thing that we happen to get into, but, most of the time that's actually a lot of work to go look, change something, look at it, figure it out, change it, look at it, figure it out, and keep going back and forth. When we know exactly what the number of difference is, one of the things that we can actually do in there is just apply an offset. So as I start looking at my configuration, okay, so let's go back into our EIGRP. Here, and question mark to see the different options that we have available to us, and there's my offset list. So offset list, question mark, alright, 0 for everything, in, so the offset is going to be 23,040 if I remember right, but we'll paste it just for grins there. And which interface? So, alright, let's go back and scroll up here and try to remind ourselves which of our interfaces was the lower bandwidth. Fast Ethernet 00 had the lower metric. Okay, so it was the best path before. Offset lists, by the way, are always additive in value, so we'll need to add it to the lower interface at that point. So boom, go ahead and put that in there, and let's take a look back at our topology table again. Okay, so route configuration changed, resynced the routers. Now, let's take a look at that. So yeah, not everything is exactly instantaneous here. Well, that's not quite as good because we only have 2 paths. So why are we not seeing anything Fast Ethernet 00? Probably still thinking about stuff. Yeah, we'll kind of leave that for a second. So one of the things we, I guess, hate in the world of networking is not being able to have instant gratification on every single thing. But let's give it a second and take a look at where we're at with it. Okay, so there we're back, and we finally resynchronized stuff on there and found that now I'm back to having 4 paths. These all happen to have that higher metric now available to it. So if we take a look and do the show IP route, see if we can scroll back and find that command. It's topology route. There you go. Might have been easier to just type it. But in any event, when we start looking at that route there, we have 4 paths available again. So it gives me the best of the selections in there at the higher metric value, but I haven't used the variance command, and I haven't gone back and either broken previous steps that made me change the bandwidth or delay values to begin with, but making sure that we're getting all the same information passed through in there. So good stuff as we happen to look at it or happen to go through. But all in all, those are really the pieces involved with EIGRP load balancing. So just one last little thing as far as EIGRP goes. Now, a lot of the stuff we don't demonstrate, the networks and how to do it and all the other fun stuff that goes with it, because most of it should have been tested already, so we shouldn't see anything out of the ordinary. But one of the things I do want to bring up that we did talk a little bit about in the theory, but I want to show you, is the part about discovering your neighbor's autonomous system. So let's go back and go into R9. And we'll go ahead and do a no passive on that interface there. Make sure that we put the right one in. Okay, so we're getting that all good there. So as we happen to see this, so do show IP EI neighbors. So right now I'm only getting things over the serial link. Up on my link there, do ping 100, 100, 250.200. At least I think that was 250. Yeah, we can always ping the broadcast address and find the address of our neighbor there. Okay, 250. So at this point in time, kind of wait and see what's going on with EIGRP and make sure that we're going to be operational. So one of the other things we can check, do show IP protocols, and we'll see on there for which networks we're doing. Well, basically we're routing for everything. We're not showing any passive networks at this point, but otherwise the only gateway that we happen to be seeing is R6. So that's what we got right now. But when we start looking at things, or when we start waiting for things to happen, the question is, where is stuff going to be coming from? So even after a while, if we're not seeing any information here, we can always test things out. So let's see, access list 101 permit IP any host 224.0.0.10. That should be EIGRP there. Do debug IP packet detail 101. Let's see what kind of information that we're going to get going on here. Okay, so not get too much in there. I don't want to bog ourselves down. Let's scroll up and take a look at. First one is source from us. So we're sending out to Fast Ethernet 00. Alright, so that's cool. Let's see, here's another Fast Ethernet 00. We're sending that out. Oh, here's one as well. Here we received one. Okay, so we are getting this information in here as far as that EIGRP hello packet. But yet we're not getting messages that used to show up about neighbor not uncommon subnet, neighbor and mismatched AS number, blah, 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 whatever. So I should be seeing this information show up, but I'm not. So when we start looking at things, so do show run section EIGRP, double check, okay, make sure we got no passive interface, no nothing else in there. Now, here's where we get to some of the details about things. So at least now at this point, we know the source address of our particular packet. So I can say no access list 101, and then go back and recreate it. Access list 101, permit IP, host 100, 100, 250.250, host 224.0.0.10. Let's go do our debug again. And we should only be seeing this stuff to, or coming from, our peer right there. Now, here's the trick. Okay, so we see this information coming in. We've got no idea what their AS number happens to be for it. So if it's not our own, which we are pretty clear about because we haven't formed a peer with them yet, but if it's not the same as our own, then really the next step is we have to create a different EIGRP process and figure out what's up with that. Okay, so we don't know who it is or what it is that we happen to be talking to. Okay, so we can do the same type of thing. So let's go through here. Look at what we got. So network 0000, do show IP interface brief. Okay, at least that gives me my IP addresses. Get to our notepad here. So put each of these in here. So 150.100.91.0. So put all the rest of those there. Then create another EIGRP process. Just call it 100 and say net 100.100.250.0 with a /24 mask. Alright, so let's do that and see if anything changes in terms of our setup there. Okay, so down, new adjacent. Okay, so we reinitialized our adjacency there to R6. That's who we were talking to before, so that's really nothing out of the ordinary. I'm still receiving information from BB3, but I'm still not seeing anything about that. So on show IP protocols here, EIGRP 66 tells me what numbers I'm routing for, or what network's there. EIGRP 100, same thing. 100, 100, 250.0/24. Okay, so that part's all good. Now, the next thing to look at, though, so do on all. So we already have our access list set up properly. What we want to look at is that same debug, wherever that went to. Dump. So dump, by the way, is a hidden command. It will not show up for you. But what we're going to get out of it is basically a hex dump right there. So there's all the fun stuff that we see. Now, do on all. Really, all you need to do is have one of these come in. They're all pretty much going to be the same thing. You look at it and say, wow, that's pretty interesting. Now, the important thing, however, is this part right here. Whoop, that one. This in binary is 224.0.0.10. That would be our multicast address for EIGRP. Now I go 1, 2, 3, 4, 5 binary words from there, or hex words from there. And that number, 1779, in hexadecimal, is the AS number of our incoming packets. So that's going to be our difference there. So let's go back to that calculator we called up, and of course go back to scientific mode, and say hex 1779 decimal 6009. That is our peer that we're going to be talking to for BB3. So, go back over here. Say no router EIGRP 100 6009, and paste that in, and now we have an adjacency. So it really wasn't all that hard. Kind of obnoxious we're not seeing the logging messages we did before, but I guess that's progress in some way, shape, or form. But it is very important to note that we can figure out who is on the other end and what's going to be going on there. So let's see, do show IP EIGRP topology 6009. And I'm going to get a whole bunch of routes in there. Now, of course, if I want this to be reachable to anybody, I'm going to have to redistribute between my two EIGRP processes, but at least I have some idea of what it is that I'm doing at that point. So all in all, that happens to be my neighbor discovery version in EIGRP. And let's see if eventually here my plethora of routes learned from the peer happens to end. There we go. So anyway, that is neighbor discovery, and that's the rest of the stuff for EIGRP.